So let's discuss about the rest of the chemical property which comes next is reaction with acid and alkali. Okay, so let's remove everything. Write down reaction with acid and alkali. Reaction with acid and alkali. Okay, alkali is base, nothing other than that. So reaction with acid and alkali. So you have to remember an important point here. Boron does not react. Boron will say I will not react. Boron does not react. So gone. Okay, next comes is our aluminium. So aluminium react with dilute HCl to form AlCl3 plus H2. It reacts with NaOH, which is an alkali. Okay, this is sodium hydroxide, which is in aqua state. Okay, it forms NaAlO2. Okay, now this NaAlO2 will again react with NaOH, give out two hydrogen to form a compound which is sodium tetrahydroxoaluminate. So it is like this. Na, it is a complex compound, AlOH whole 4, like this. This is sodium tetrahydroxoaluminate. Okay, and the oxidation state of aluminate is 3 over here, or aluminium. Okay, next we will move to the reactivity towards halogen. Okay, so give the heading reaction with halogen. Okay, now if we consider the boron family as E, elements of B family. Okay, now they react with halogen to form compounds of like this, E plus X2. They can form EX3 or EX. Okay, now here to note an important thing that TLI3 is not exist. TLI3 does not exist. Okay, now here you have to remember a particular thing, that is again the stability of +3 oxidation state decreases down the group. Okay, and +1 oxidation state increases down the group. Again, this is due to IPE, which is inert pair effect. Okay, so you copy up to this much. Next I will come about the reducing property. So let's rub it out, and now let's discuss about the reducing property over here. So reducing property, let's do this in form of a question. Okay, so write the question over here. Question: compare reducing power of Ga Cl3 and GaHCl, sorry. Okay, so think about this question a bit. Think. Okay, let's come with the answer. Now we know here we have to do this way. Stability, we know stability of Ga plus 3 is much more than Ga plus 1, right? So Ga plus 1, which implies Ga plus 1 will have a tendency to get oxidized and get converted to Ga plus 3, right? So it will go there and get oxidized. Let's write here oxidize. Okay, which means that GaCl2. So if we have studied in redox that if an element is getting oxidized, that means it is a reducing agent. Okay, so which implies GaCl is a better reducing compound. Okay, copy it down. Let's take another example of this type. Let us do with important thing which I have mentioned previously. Let us rub it out this portion. Okay, so let's rub it out. Okay, let's write over here. Same question, compare. Now let's compare the oxidizing power. Okay, this was reducing power and this is oxidizing power. Okay, let's see what is said here. Of TlCl3 and TlCl. Think again, pause and think. Okay, thought. Let's start with the solution. Okay, let's start. So we know the stability. See, this is an exceptional stability. We know Tl plus 1 is much more stable than Tl plus 3. So Tl plus 3 will have a tendency to get converted to Tl plus 1. So what is happening here? It is reducing itself, right? Reduction. So it is reducing itself, right? Which means that TlCl3 is better oxidizing agent. Okay, this is important. This came 1 year in boards. Okay, this is, I guess, Cbse. Okay, this is important. Copy it down. So this was the end of the compounds of this. This was the end of the properties of the boron family. In the next videos, I will come with the properties of the compounds of the boron family, which is of borax, diboron, and boric acid, and like that. So copy it down up to this much. Coming in the next video. Thank you.